Okay, here are my answers. You should copy them down. And you can ask me during class if you have any questions about those. Copy, 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 pause, pause, copy, copy, pause, pause. Okay. Let's see. What does t of x equals ax do visually, let's say, if a is equal to, if a is equal to 0, 0, 0, 1, b, a is equal to 2, 0, 0, 2. So what happens visually? Well, for the first one, a times x, which I will write as 0, 0, 0, 1 times the vector xy. So what happens here? You get x times 0, 0 plus y times 0, 1. So you get just 0 y. So t of t applied to this vector xy. Therefore, t of xy just kills the first component. So visually, what does that do? Well, if you have the xy plane, and then let's just say your vector goes like this. You could put x there, and you could put y here. Now, the transformation just smushes the x component. So my output is there. And in words, we say this is a projection. It's a projection. You could imagine a light shining, say, this way. And the shadow on the wall over here is what you get. That's called a projection onto the y-axis. So that's what t of x ends up being. So equal sign there. Okay, b. You have a vector. Oh, if you have a vector, say xy, well, what happens to it? T applied to xy is a times xy, which is x times 2, 0, plus y times 0, 2, which is 2x, 2y. So you get this doubling. You get double the original vector. So it's something like that. So if you start with the vector x, then t of x is just 2 times x. And we say scaling by a factor of 2. Okay, all these calculations remind me that I've forgotten to teach you something. Uh-oh. So this goes back to 11.4. What I'm about to say. Let's go the row vector rule. For AX. So the row vector rule for the product of a matrix times a vector. So let's take an example that we just did. Like this one right here. Okay, the rule says that if you want to do this product 2, 0, 2, xy, okay, you can either do it the way I originally defined, or you can say to yourself, well, my answer is going to be a vector with 2 entries. Excuse me. And to find the first entry, I can do this guy times this guy, so 2x, and then add this guy times this guy, 0, y. And then to find the second entry, you just use the second row now. You take 0 times x, and you add 2 times y. And then you will get the exact same answer as I got up here. So we'll call this an example. Let's do another example. If I have, say, A, B, C, D, E, F, these are little numbers, and I have R, Q, P, whatever. And what you're doing is, well, you can think of it as, if you've done dot product, maybe you know what this is. You in a sense multiply these two things. You take this row and you take this column and you multiply corresponding entries. So first entry here with the first entry here, plus second entry times second entry, plus third entry times third entry. And then to get the next entry in my answer, I'll go with this row here. First entry of the row times the first entry of the vector plus EQ plus FP. So that is, I think, example here really summarizes well. So what we're saying is you can do this product here in another way. And it's equivalent to the first way I showed you.